Thank you all very much for heading out on this beautiful New York evening. I know there's other places you can be when the weather looks this beautiful after some cold, cloudy days. Thanks to DigitalOcean for hosting us. Thanks to Nancy back there. She is the fine person responsible for the great spread, Taco Tuesday. We normally host these things on Wednesday, and I think I'm going to start doing them on Tuesday. This is the outcome. My name's Ariel. I'm the organizer for the New York Kubernetes meetup. I'm one of the founders at a company called StackPointCloud. And big thanks again to DigitalOcean for hosting us. I'm curious because now we're doing like joint meetups with New York, with the DigitalOcean New York meetup. Who's here from the DigitalOcean New York City meetup? Awesome, cool. And I'll assume everybody else is from Kubernetes. How many DO users in the room? Aha, yeah. Well, so do you guys have a choice back there? Or we have some of DO engineering. For those DO users, if you want to, what monitoring team? Is that what you guys do? Okay. So if you have questions about monitoring a DO, go look over there. So DO Kubernetes 15 is a coupon code. It will give you $15 for free at DO. With that, you can go on StackPointCloud, spin up a Kubernetes cluster if you're interested. Coming up, CoreOS Fest. Who's going? San Francisco? What? Jonas is going. I don't know if you got a ticket, but Fest 20 will give you 20% off the full ticket price. And that is happening May 31st through June 1st. Is Paul around from CoreOS? No Paul. All right. So on to the speakers. First up, the big Lombardi, straight from Boston. Senior platform engineer at Datawire, where he is building a development platform aimed at small companies adopting or using microservices with a need for their platform to be simple, resilient, and adaptable to the ever-changing tech landscape. And if you're working with Kubernetes, it is rapidly changing landscape. He also comes up with really witty Twitter handles. We also have John from innRoad. He's the technical lead there with a focus on their internal platform. At innRoads, they're implementing a complex management system for independent hoteliers. Did I say that right? Following domain-driven design and built on a service-oriented architecture. So he's going to tell us a little bit about what they've been doing there and how they've been leveraging Kubernetes. So that's it. Thank you so much. I'll give way to Phil.
All right, thank you, Ariel, for the introduction. I'm really happy to be down here today in New York. My name is Phllip Lombardi, and I come from Boston, Massachusetts, where I work for a small startup called Datawire.io. Datawire.io is helping customers basically either migrate onto microservices, because they already have monolithic applications right now, they want to adopt microservices, or we are helping customers who have basically adoption issues with microservices, figure out new techniques to accelerate their business with microservices on Kubernetes. And so like some of the stuff we're doing with Kubernetes is we have things like we are building around Lyft's Envoy for basically an API gateway. We are working on a provisioning system that wraps kops and Terraform and actually handles doing some of the really nitty-gritty work that actually is kind of left open to most engineers. And the thing I'm going to talk about a little bit later is a tool called Telepresence, which allows you to basically bridge a local laptop into a Kubernetes cluster and have a shared environment that will not only give you network connectivity, but volumes and environment variables that are bridged between your local laptop and the Kubernetes cluster. So what was so special about 2005? 2005 was kind of a rocking year culturally. We got YouTube, which I think all of us use every day probably, to watch videos, cat videos, dog videos, music, whatever. We got Star Wars, Revenge of the Sith, which some of you may love, some of you may hate. My personal opinion is it's pretty awful. Hopefully Disney reboots it. We got Guitar Hero, which I am sure everyone in this room has played and rocked out drunkenly at 3 in the morning pretending to be Jimi Hendrix with their friends. We also got American Idol, which is still actually pretty popular. And according to my coworker, we got Wedding Crashers, which was really popular in 2005. I have seen it, but I didn't remember it came out in 2005. Also, in 2005, we got the Patriots, and it wouldn't be a Boston person down here in New York ringing on you guys if I didn't mention that we collected one of our rings that year, and we trounced all over the NFL once again. But I digress. I am not here to talk to you about how awesome Tom Brady is and the Patriots. I am actually here to talk to you about what development was like in 2005. And so you can't start a conversation about what development was like in 2005 without basically talking about this, Ruby on Rails. Ruby on Rails came out in 2005, and it kind of changed the way people built web services and web applications. You basically had this thing you could install right off their website. You could start editing code really quickly. You could save it, and you got a reload, and your changes were present. Ruby on Rails also really helped you basically with things like database migrations, with handling your models for definitions on the database side, and it made basically developing super simple. That super simplicity led to massive adoption, and that massive adoption led to companies building products really quickly, and then those companies grew and got bigger and bigger and bigger and realized that their little Ruby on Rails application they had built to show their investors suddenly was no longer a little Ruby on Rails application and was several million lines of code and spanned many, many people on a single team or many teams, and there were conflicts with this. The paradigm of edit, save, reload still worked, but it wasn't scaling for them. So they started to adopt microservices. But developing microservices is really not as nice as coding on Ruby on Rails. You, for one, don't usually have a single framework that you're using. Your company may want to try and enforce a single framework. It may say you all will build Ruby on Rails or Sinatra or Play or whatever language or paradigm or framework you guys are working in, but usually it doesn't work out. Acquisitions happen, other engineers come on, someone wants to accelerate something and they pick a new technology, and suddenly you are dealing with a polyglot framework and you have services that are, you have to depend on other services. So developing microservices just really isn't as nice, and it's because of all the facts of a distributed system. You have just many, many components to work with. You have the situation of services depend on other services. You've got microservice 1 depends on microservice 2. Microservice 3 is dependency of microservice 2, and if you're really unlucky, you've ended up with microservice 3 depending on microservice 1, which gives you that beautiful circular dependency tree that we all do not ever want to see. You also have the problem of services end up depending on cloud resources, or for those of you who are working in on-prem systems, that cloud just extrapolate it to your data center or whatever you're working with. You need a way to get access to that stuff in your local development environment. You may need to do that for a variety of reasons. For one, if the data is big enough that you're working with and that you can't spin it up on your local machine, you'll need to connect over to the staging environment or the dev environment, which has pre-sanitized data, pre-aggregated data, whatever. And last, but your laptop is nowhere close to anything like a prod environment. Even if we try to simulate it, you're just never going to get there. It will never run everything it needs to. You may not set up things the way they are in prod. For example, you may not set up the HA active MQ cluster you actually need, but the prod guys are using. But you have something that's kind of like a standalone thing, and it works. But point is, you end up with configuration drift or other types of drift that lead your laptop to not be at all like the thing you are running in production. So what are we really to do? Well, this is kind of I'm going to talk a little bit about the 4 different strategies we've seen our customers and our prospects using. They have kind of adopted, depending on where they are in the process of adopting, a bunch of different methodologies. There is everything from you're going to run everything locally on your laptop and attempt to do that, and that works for some guys and some gals, but there are also companies that are doing fully remote development where basically everyone SSHs into a shared development environment. All of these are valid strategies, they just have different trade-offs. So let's talk a little bit about the first one. Everyone is familiar with this, coding locally. And coding locally basically means you're going to spin up the entire stack for your microservices onto your local machine. And so most people start accomplishing this with, say, something like Minikube as one of the tools, or Docker Compose. If you go back further, to like 25, 27, people were using things like Vagrant to spin up virtual machines, and it worked pretty well. It is a solution for a small set of microservice users. You can basically spin up the whole thing, connect to it, you can change things as you need, you can kill things as you need to, and that works great for a certain set. So the cons of this setup are that you basically have to have the problem of, one, you have to maintain all this stuff. You have a local stack, and it's defined somewhere, hopefully in GitHub or some other source control mechanism, but it is a fully it's defined for running on a laptop, not for running in production. So it has to be defined separately from your production setup, which means there's drift not only from your production setup, but there's also definitional drift as things change. If you are working with a team of coworkers, they may be changing things, you may be changing things. You won't find out about that change until they tell you about it. So it's basically a pull model for learning about changes in your infrastructure and what you're coding against. That's not great. Also, it just doesn't work for as you get bigger. You have the problem of, well, 5 services I can probably run. I can probably even run 10. I might be able to even run 20 services. But 30, 40, 50 services, or when you get up into the Netflix-sized Death Stars of thousands of services, and all of those things are JVM services, and they're eating up between 2 and 5 gigabytes of RAM, good luck. Your laptop isn't going to do it, and you can't buy a desktop on the market for a reasonable enough price that your company is going to say, yes, we're going to let you do that. So that doesn't work. It also doesn't work as your team scales. So you get up to the situation where you have 50, 100, 150 developers, and you have hundreds of services. You end up with people duplicating services because they don't know other services exist in the stack, and you're trying to spin it up. Developers may be working on things in parallel that just don't exist. Anyways, point is, it doesn't really work. And as I mentioned, like dev prod differences, that's just a continuing problem here. You also have the problem of, what about data? So some of us are lucky enough to work on small data sets where we can synthesize them at will. But many of you in this room probably work on, say, medical data, financial data, personal, other kinds of personal identifiable data. You don't have the luxury often of either being able to spin it up or copy it over. You need to connect into some kind of controlled environment or have access to a massive cluster where the data is stored already. So this just doesn't work for that case. Logically, then, people end up in the, let's just run the business logic for what we're building locally, and we'll use cloud resources or on-prem data center resources and connect everything. And so you end up doing something with, say, Minikube and Docker Compose once again, and you end up writing some custom shell scripts or Python, or you wrap Terraform and Ansible or whatever, and you end up gluing it to what is running for data in the Kubernetes cluster used for production, or Amazon Web Services, or cloud platform for Google, Azure, whatever. But it's kind of it's not any better than what you had with the previous setup. Yes, you have extracted away your data, and you're running it over in the cloud, so you can still get the benefits of having some of it offloaded, but you still need a way to basically run all those other services locally. So you still have the problem of setting this thing up. You still have the problem of configuration drift between dev prod or just dev and other dev. You have basically the problem of, you still need a more powerful laptop if you're going to be running these things. Business services, even though they're not doing too much data storage or keeping things in memory long term, are probably still eating up piles of memory, especially if they're, once again, a JVM service and they are in the memory hogging realm of operations. And so, you've solved a small problem, but you haven't actually solved the real problem with your system. And a lot of people do this. It's just the natural progression from the previous situation of, I have all this stuff running locally, I need to do something with the heaviest and hardest things, move them off. And this is out of order because I forgot to change the order. So we had 1 and 2, and we're on 4, but it's actually 3. So this option is kind of, I've heard some people use this. I've been told people use this. I have never actually done it this way, but it's basically the all remote development model, which is your computer actually acts basically as a dumb terminal, and when you want to work on something, you SSH into a remote system and you start coding on it. And it's really simple developer setup. Your developers basically need to be able to use SSH. They pop into a shared cluster and you can start hacking on things. That's great, but it has really bad tooling support. So good luck, if you're using anything besides, V or Emacs, you're going to find yourself struggling to set up IntelliJ IDE to work from your local machine over SSH connection. You're going to struggle probably getting your profiler, your debugger to work, or any of the other tools you really want to. And it just has the problem of that it's particularly slow feedback cycle for changes. Like you can hack on things in the remote cluster, but it's not a guarantee that whatever your ops guys have set up is allowing you to just see those changes immediately. They may force you to still go through some kind of deployment pipeline just to see the change in that staging environment. On the other hand, it's a really easy thing for your operations team to actually set up. They basically just have to copy prod, and they can do that in a on-demand type fashion. So every developer, when they want an environment, can basically get one by hitting some web service, which will spin up the whole thing. Or they can do something like a nightly build, and every developer gets a fresh new nightly copy every night at their request. Or you just let it run forever and ever and ever, and it's a living system. But that's, simplifies ops problems. Doesn't actually simplify developers' problems. And this problem, you have the other problem I didn't really touch on in the previous slide either, was you can't code on this locally. So, sorry, you can't code on this offline. So if you are like me and you travel around a lot, either doing talks or you are going to customer sites, then you have the problem of when you're on an airplane and the Wi-Fi doesn't work, you are kind of out of luck, and your engineering manager will look at you disappointed. Why didn't you commit things? Why didn't you fix things? Well, because there was no network connectivity, boss. So that is a big problem for a certain segment of developer. But as I mentioned, it's really easy to set up. So all remote development is great. You can set up everything really easily. Just copy your prod stack, have a way to SSH into it, and go. And it's somewhat popular. There's a company in Boston called HubSpot, which is pretty large in the marketing and ad tech space that uses this paradigm for work. But what if we could get something a little bit better? What if we could get something where we work on our one service locally and all the other services are remote? And so there are a number of ways people have actually tried to do this in the past. It's, people would use OpenVPN, people would use kubectls port forward mechanisms. These are all techniques you can use, and I'm going to talk a little bit in a minute about this Telepresence thing that, it's an open source project we've been working on at Datawire, but they're all kind of, the idea is you have this remote cluster already available. Don't try and force everything to go through it. Basically bridge the necessary things people need over into your local environment so you can still use all your friendly local environment tools. You can still code as if you're local. You can see changes immediately as if you were hacking on it locally. The idea is basically get back to that Rails kind of edit, save, reload, see the change. And the added benefit, since you're working in a shared cluster and you're working with a team, you can edit, save, reload, and all your coworkers will see that change as well, which I'm not suggesting you do this for prod. That would be crazy. But it's an awesome experience if you're a developer and you're working on a team and you're working on a brand new prototype for a feature. So I kind of put up all these things, the way to do this. These are kind of the differences between the different technologies. People have tried to do this a little bit with the OpenVPN, and OpenVPN is secure communication, and it's a bi-directional network, so you can talk to things in the Kubernetes cluster, and you can also talk to the Kubernetes cluster can talk to stuff that is running on your laptop, but it has the big problem of basically OpenVPN, or really any VPN, is a nightmare to configure and get actually running. And then there's also no support for basically any of the Kubernetes primitives that you're used to using, like volumes or environment variables. So it's really only for networking. Similarly, we have this kubectl port forward mechanism, and it's easy to set up and use with a small number of services. It gets a little bit more tedious if you have lots and lots of services that you want to port forward for, but you can do it. You can write some scripts around it. You can make it happen. But it's unidirectional. It's your laptop or your desktop over to Kubernetes. It is not a bidirectional link, so you cannot have a developer on another laptop talk to you because it's talking through Kubernetes and your service is represented inside of that Kubernetes cluster as if it was right there. And so it has also, for that fault, no proxyability for Kubernetes volumes or environment variables. And then there's this telepresence thing, which we've been building, which is bidirectional networking. So you can talk to the Kubernetes cluster can talk back to you. You have the ability, it's really easy to set up and use, which I guess is completely subjective, but I promise it's actually not that bad. And it's got the ability to proxy Kubernetes environment variables and volumes across, from the Kubernetes cluster into your development environment. So let's talk about that single service local or end services local that you're hacking on and all the other services remote. You still get to use your local dev tools, which if you are using anything more sophisticated than a text editor is awesome. You still get to have the benefit of a fast feedback cycle. You still have the simple developer setup, and it's really easy for a developer to set this up. It's open up a text editor, start working, open up Telepresence, start working, or open up, if you're going to use the other two technologies, open up the connection for OpenVPN, or open up the kubectl port forward, sorry. It's really scalable, so you're not actually going to have to host any of these things on your laptop, except for the service you're working on. All that other stuff is running off in the remote cluster. And it's just kind of it's a more realistic environment than anything you're going to get otherwise. And why is it more realistic? Well, because you can basically have your operations team copy prod every night or for you on demand or whatever. And so you're actually coding against what would be a very realistic prod environment. But there's still the drawbacks of can't code offline. And you can't really, it is complicated for ops to set up in the sense that if they want to do the more advanced thing of bidirectional networking with also the Kubernetes proxying stuff for environment variables and volumes, they need to figure that out. And they also need to figure it out in a way so that if you want to share it between n number of team members on your team, that's on them to figure out. And so it's not really like, it's not to say it's hard for them to do from a setting up the environment. It's hard to do from a, let's get it so it's a good developer experience. So that's the kind of the 4 strategies that exist. There's this kind of handy eye chart that I've put out here, which has a bunch of subjective little hexagons on it about where these things kind of help out. You've obviously got, run system locally is awesome for fast feedback cycles, but it has its issues with low setup maintenance and realism and scalability. You kind of have what you get to next, which is the run some things local, business logic all the business logic locally, and all the data services in the cloud, and that solves and makes things a little bit better, but you get a kind of worse fast feedback cycle. You can do the single service local, all other services remote, which is pretty good. It's got great scalability. It's got okay feedback cycle. Low setup is for developers. Maintenance is kind of is still just a sunk cost no matter what for operations since they have to maintain prod. And then there's the all remote development, which has a poor feedback cycle, but has probably the best features across the board for realism, low setup, and scalability for everything else. Anyways, I kind of want to talk a little bit more about this single service local, all other services remote option. So we talked and we said it's a mostly realistic environment and it's complicated for ops to set up. And so what if I told you can get basically a perfectly realistic environment and you could get it so that your operations team didn't have to think at all about how they're going to handle making it a solution that you can basically hack on with all your developers in a way that you can expose your Kubernetes cluster to your local machine easily, and your local machine is exposed to the Kubernetes cluster easily, and you can share that with your entire team. Cool, wouldn't it be? Yes. So we got this thing called Telepresence, which we built as a synthesis of a lot of the things people have been asking for. It's basically Telepresence becomes a pod that runs in lieu of the pod that your actual service would be on the Kubernetes cluster. So say you write a deployment manifest, instead of actually having a Docker image for the service you're actually going to run, you basically spin up this Telepresence pod instead. And what Telepresence does is it actually proxies all the network requests, all the environment variables, all the variables, all the volumes that are actually connected for that deployment over to your local client. And so basically when you're actually coding, you are coding locally on your file system. You are editing files on your file system, and everything else is seamlessly occurring behind the scenes. So like you could even connect up a cloud load balancer in a way so that when you have like an ELB, the traffic from that ELB will end up on your laptop. And it's open source. And it's kind of, this is kind of a poor diagram that I hacked together 30 minutes before this presentation, because my coworker was like, you gotta have something to show like how this actually works. There's two proxies. There's a SOCKS proxy, and it's kind of being facilitated by this thing called the TorSOCKS library, which is basically intercepting basically socket API calls, low-level system socket API calls, and handling like a whole bunch of stuff, proxying over to this Telepresence container, which is handling some more nitty-gritty details. I could talk more about that, but I guarantee you the webpage for Telepresence actually does a better job explaining it than I can do in person and orally. So it has diagrams and stuff for the people who are really technically curious. So I highly recommend checking that out. I'm going to do a little bit of a demo actually. So I have got a Kubernetes cluster spun up for this thing here. So let's make sure I'm actually connected. Cool. So I spun up this Kubernetes cluster earlier today for doing this demo. And so I'm going to show you right now that it's got a couple things running on it. It's got, it's got a couple services. You're going to see there's, sorry. Yeah, I'm going to use my lap, use my mouse. And I'm also going to sit down because it's easier to do this while sitting down. So, how does this actually look up there? You guys see? You want me to zoom in? Does that help? Okay, maybe a computer doesn't want to zoom in. Why does it not want to do? All right, fascinating. So we'll do it with good old. Is that better? Everyone can see now? Awesome. All right, so I've got a couple services. I got this hello world service. I got a counter service, which is basically just doing an increment of a bunch of basically a Redis thing. We got Redis running. Redis and the count server are running on the Kubernetes cluster themselves. And I'm going to show you, like, there's no magic going on in any of these things. Count serve is going to look like, there's no magic here. It's just making a Redis connection, opening it up to the Redis that's running on the Kubernetes cluster right next to it. And so that's cool. It's also, we're going to show you the hello script. Where am I? Sorry, guys. There's no magic in here at all either. It's making a request to the count serve. But the hello thing is actually not running. The hello service is actually not running on this Kubernetes cluster. It's actually not running anywhere right now. The only thing that's running is going to be the Telepresence proxy. So let's actually describe the deployment for hello world. So it's actually, it's not what I want to show you. No, what I want to do. I will show you really what's going on. All right. Ignore all this PGSQL stuff. This thing here, this Datawire Telepresence KNS, with a version number after it, that is the proxy that's running on the Kubernetes cluster. So if you were to think about how you were previously working on this hello world service, you may be spinning up a hello world, Datawire/hello Docker image. That gets replaced. You basically comment that out, you put this in, this Datawire Telepresence KNS042 in, and you go. And so I'm going to show you what that actually turns into. You do this telepresence, you tell it what deployment it's going to use. So we're going to use the hello world deployment. We're going to expose port 8080, and it's going to drop us into a shell that is transparently got all this stuff going on behind the scenes. All right, so the shell is booted up. I'm actually now part of the cluster. If I do an env, you're going to see that there are a number of Kubernetes variables actually dumped into this. You'll see things like the hello service port, Kubernetes ports, all that stuff. That's all coming from the cluster itself. I'm now going to start actually hacking on the Python app. Let me boot it up. Oop, sorry. All right, there we go. All right, so that little Python app is written in Flask. It should be pretty easy for us to basically edit it in a minute. But so assuming the load balancer has picked this up. That's not what I want to see. All right, cool. We're up and running, and it's running locally. But has the load balancer picked it up? It should. Yes. So that is actually being basically, that New York C cube.d6e is actually going through a load balancer to my local laptop. So it's going through an ELB on Amazon. It is routing through Kubernetes and into my laptop. Let's change the code for hello to do something with some of those services that we were actually looking at before. So we're going to hack on hello.py. Oop, not hello.py. So we've got this that count serve, which basically just increments a number for every time it comes in. Let's uncomment this code and actually use it. Remember, that count service is actually running on the cluster. So comment that out. And we'll see that Flask automatically reloaded the code for me because it changed. And I can now do this. And this request number 8 I have received. That is showing you that I can edit that code locally on my machine. It is proxying everything over to my code that is running on my machine. I am utilizing a service on the Kubernetes cluster. So I'm utilizing the Kubernetes, the counter service that I wrote earlier. And it's also utilizing a Redis database in the back end on that counter service. So pretty cool. We could actually, we could do more hacking here, but I'm not gonna burn out everyone's time. Kind of flipping back over to this presentation. Hopefully it's not, yeah. Anyways, so a little bit more about this implementation. How are we actually proxying this network? So on Linux, we basically hook into LD preload, and on Mac OS, we basically hook into the dildy insert libraries. And they're dynamic linker features that allow you to inject new libraries and new library code into any binary that's running. That new library can then override system and library calls. And so we actually use this library called torsocks to intercept all the socket library calls that are coming out of your system and change them up and route them over to the proxy. And then the volumes, which I didn't show right now, are basically actually being handled by this tool called SSHFS underneath the scenes, and environment variables are really easy because you just copy them over. There's no real magic there. Anyways, thank you for your time tonight. Please check out telepresence.io. You can email me at plombardi@datawire.io, or you can hit me at on Twitter as the Big Lombowski, which I probably should have put on here. If anyone wants cool stickers, also I have stickers. So if you want the cool sticker of where is it? Here it is. We have these little Blackbird dudes with basically VR goggles on that I am happy to hand out. And you can plaster them all over, and I hope to see them all over New York City, because that'd be awesome. Anyways, thanks, guys.
Questions?
Yeah, absolutely.
Questions? Hold that.
So during a development process, is the work that gets reloaded tied to a directory, or does it anywhere on the file system you can make any changes?
So you can do any, the question was basically when you are hacking on something on your machine and it's tied to the local file system at all, and so is it tied to a directory, is it tied to a particular file? The answer is no. So it's up to you and whatever tool you're using. So I used Flask right here, which has an automatic reload mechanism. So when you change the file, it sees a change and then reloads it, and your code is basically hot swapped. That would not work, say, for a Java developer who needs to do a recompile. So you'd have to stop the thing, recompile, restart, but it would just seamlessly recover afterwards. So It's not nearly as smooth unless you had something that was doing like dynamic class reloading, but same idea. And so it's not tied to any particular directory layout or any particular process or any implementations like that. You can do whatever you want. It could be a text file. You could have done something with like netcat and echo and a file if you really wanted to and called it a day. Does that answer the question? Awesome.
Is it just SSH to the cluster, or is there?
It's no. It's a. So the question was, is it just SSH from your local machine into the cluster? No. We're intercepting socket, low-level operating system socket calls by injecting in this TorSox library and then changing things. I cannot actually tell you more about that. The guy who actually wrote the code for this isn't here tonight. He was originally going to do this presentation, but he had personal things that came up. So I'm doing this. If you go to the website, it explains a little bit more about what's going on in detail, but I can also put you in touch with him if you would like, and you can have a full-on conversation with him about what's going on underneath the covers.
Is there any limit to what you can project secret-wise from the cluster onto your local service?
Sorry?
Secrets from other namespaces. So if you're running a service in a certain namespace, do you have access to secrets from other
You
namespaces?
have access to what's in the namespace. If you want more filtering, that we can take a feature request. Or if you want more expansive, like you can see everything, I guess we could also take a feature request for that. So yeah, it's on GitHub. Just check it out, open an issue, and we'll work on it.
Thanks.
No problem.
Just a quick question. Is the DNS, does it use the Kubernetes DNS and everything?
Yes, it's using the Kubernetes DNS.
Okay, so if I have multiple deployments in different namespaces, depending on which shell, it uses the different
It uses the
search
correct
order?
one. Yep.
Okay.
Are there any bugs or gotchas? We've tried to do transparent proxying of, say, Java before, and it doesn't use standard system calls for DNS. For instance, it tries to do its own.
So it's alpha
bind
software. There's
querying.
always bugs and issues that we have not run into yet. But we are happy to work with you. If you have an implementation that you already tried out, or you have some test cases that you'd like us to actually go through, and you want to open an issue on the GitHub repo, we will be happy to work with you and go through those issues and see if we can either we've already solved them or there's something we need to work around. Happy to work with you on it.
Is it one-person dev environment, or it's a full collaborative environment, this setup?
So it's a full Kubernetes environment. So is the question?
I mean, is it possible to have multiple proxies to different services, so each developer on his own laptop working on different service in the same Kubernetes
So every
cluster?
developer could have their own proxy into this Kubernetes cluster. So you could have a fully on shared Kubernetes cluster.
And if someone takes his laptop away, basically the service dies.
It's like a service dying, exactly.
Okay.
So it's a way of simulating a failure case, I guess. Don't use it in production. I really don't recommend using it in production.
Cool. Anything else? All right.
Awesome.
Thank you very much, Phil.
Thank you for your time, guys.
We have John Delivuk. Delivuk. All right.
Cool. No one's seen this screen before, right? Like, first time tonight, brand new, cool stuff. Maybe not. All right. Hi. So I guess let's start with the PowerPoint, because those are always fun. And we'll continue. Cool. So real quick, my name's John Delivuk, technical lead of development operations at innRoad. I won't bore you with what innRoad does too much because we're business to business, focused on hoteliers. Tech industry, maybe not so much interested, but what we do, we really, really enjoy, and we're very inspired by what Netflix does when they contribute pieces of software and methods to the community. So that's why I'm here tonight. Quick show of hands. I'm assuming most of the room running like Kubernetes clusters in maybe development or production? Maybe? Cool. For these groups, Ubuntu, CoreOS, something else like Ubuntu, you guys with that, or Debian-based images? CoreOS? CoreOS? Okay. And other? Yeah, that's what I figured for other. I figured those two were it. For us, we went with CoreOS. We really liked how it was built. If you look at the repository and you look at the number of components in Kubernetes that are now dependent on CoreOS and vice versa, that it's a magical coupling. So we have to accept credit cards. This makes us PCI DSS compliant. We are not right now in the best place. We acquired we inherited an application, and as we've been through refactoring, we've implemented Kubernetes. We've taken domain-driven approaches that are underlying with microservices. What's the difference, you say? We have bounded context. So we never really worry about necessarily the server cluster running. We are more focused on each service respecting a contract that the service publishes. This allows much more minute testing, and then we again do some overall end-to-end testing just to smoke check. I'll tell you some stuff about what we do to secure our Kubernetes cluster, but I will not guarantee that this will pass your audits. At the moment, we are level 2 compliant. We're moving towards level 1, reinforcing everything, but we haven't made it there yet. So a little bit about innRoad. I joined in 2016. Traditionally, they used a lot of Microsoft, which is completely the other end of the spectrum from Kubernetes and microservice implementation. BizTalk is ugly. I hate it. I still have nightmares. I don't know why anyone ever used MSMQ, but we knew that there was change coming. So we migrated to AWS. We started building things in Docker containers, and we started building fast. We needed to manage them. We evaluated ECS. We evaluated Rancher, and we evaluated Kubernetes. Didn't really care about Mesos. We loved it. We went with it. Our business is also incredibly event-based. When people go in and they book a reservation through our partners, we're generating events that need to propagate quickly. When you're changing status of rooms, this needs to go quickly. Synchronous operations kind of suck. So a task worker model, our friends. One more thing I'll say is we also implement all of our microservices now using .NET Native, .NET Core, Python, and Node. .NET Native is being phased out because it's a pain in the ass to run on Kubernetes if you want to run Mono, and why when you can run Core. A few other things. Straight bullet point. All right. We don't always necessarily use microservices. We really love our relationship with AWS. We're huge on Lambda and its implementation, but we find Lambda having a lot of shortcomings, and that's why we're constantly going deeper into what Kube can do. We love 7-factor app implementation, configuration design. We take it into consideration. We were actually really disgusted when AWS announced that, follow 7-factor for implementing software on our system, and you'll have a good time, but yet then Lambda doesn't support environmental variables, and their solution was really preposterous. And the first bullet point, DevOps isn't just Jenkins or Circle CI and something else to deploy it. It's about a feedback loop about finding your smallest or your slowest component and then eliminating it. Traditional QA infrastructure development models, they don't work. Well, they don't scale. They work in some situations, but we need every person who is the expert on the front line for their application. So we have this giant application. We need to make sure it's secure. We need it to interact with a lot of applications that are not necessarily going to be running Kubernetes. So we looked at Kubernetes and, all right, how are we going to do security? Because if we do Google searches, we're not seeing a lot on it. Like, yes, there's authorization features, but what are the things that are going to come up when we're being audited? when you get into AWS with Kubernetes, you're looking at a lot of layers of networking, and management can be cumbersome, but actually Kubernetes was a big helper with that. Installing shit on CoreOS just doesn't work. So coming back to that, a lot of these bullet points may be geared towards CoreOS implementations. If you have Debian, you can just do it the old way, but I think going through the pain of implementing through CoreOS helps significantly. So here we are. We're going through, we're now running 60 services handling secure information in our Kubernetes cluster. We love the idea because now, unless you're doing something incredibly wrong, you're no longer storing state to local disks. You know, don't map anything to your local host node because it has to be an unencrypted EBS volume for root. Save it to an external volume and encrypt that. Oh, in AWS? Oh, you can? Yep. My mistake. All right.
Sorry, didn't mean to throw you off.
No, all good. I think I haven't had to deal with that on the Linux side. On Windows, I think it's still a limitation, right?
You have to, well, you have to create your own, go into KMS, create your own key, and then create your own AMIs from their AMIs with your key in it. So
Gotcha.
Right. They have a whole page on it.
Gotcha. All right, I'll update that later.
Sorry.
All good, no. You know, you look at a lot of what security software does. You end up wrapping things, sysd for making sure that the daemon's running, or running other monitoring softwares on top. And Kubelet's actually feeding all that information back to your Kubernetes cluster, which again integrates with other things like Datadog. Daemon sets are our friend, and with our .NET native apps, we were also implementing, you know, that full kind of like stack where it's EC2 auto scaling, code deploy, elastic load balancer. And it's not making it easier. Like, cool, you're getting this great package wrapped up for you, but it's not, like when a developer has to go in and troubleshoot, they still have the entire system exposed to them. So go Kubernetes, deployments, services, I love them, they're my best friend. Going deeper into the PCI compliance, sorry if it's a little fuzzy. Main points from their documentation. We're gonna just step through them a little bit, talk about do's and don'ts. And starting with building and maintaining a secure network. You don't really have to change a lot with Kubernetes. Using SSL offloading, because PCI compliance only cares about over public network. So things like ELB offloading are still your friend, which are really, really awesome. The etcd cluster, try to remove that from your API server. I think like if anyone's familiar with the Kube AWS tool, traditionally they wanted to install your etcd on all of your kubelets, which is kind of counterintuitive. And etcd is the only place where you're managing state in the cluster. So in Kubernetes, you typically wouldn't be storing secure data, but if you're using environmental variables, you're now securing something, you're storing something secure. If you're using config maps unencrypted, you're storing something secure. And yeah, skipping over a slide, bad jokes. Into protecting cardholder data. In the Kubernetes cluster, it's not really going to be looking at your data. You're running stateless microservices. Data will always be transient, so you can use SSL when necessary, but your Kubernetes cluster will be in a private network, ideally. Things that can do and help, EVS volume encryption, KMS the data as it moves through the application. You could use something like Kube to IAM to handle more granular key rotation and access control management. I personally, you could write to your Kube node storage and map back to your host volume. I don't suggest it. Always use read-only. And if you are using passwords, either use your authorization to lock out the respected endpoints for your users who don't need them, or encrypt them first and then save it, give your containers access in. Into the vulnerability management, this was the most exciting part. So in Debian, yeah, nothing really changes here. We you can just continue to use the same old tools, install them manually, install them with Chef, Puppet, Salt, whatever flavor you want, if you want to go that route. In CoreOS, we kind of don't have that. So I've been chatting with Brandon Phillips on Twitter, who is always like awesome, replies instantly. I don't know how he has the time to do all this, but we've been talking back and forth about doing daemon sets across the node. So at that point, you're reporting everything back to your cluster. You can monitor for events. We use Datadog on top of that, so you can see if anything's having issues. For the antivirus, the implementation's still going on for us. The plan is to wrap or to map the host volume to a subdirectory of the container and then do scans on that. And then we can raise alerts as needed. Yes.
You have CoreOS set up for the automatic updates?
Yes, but they're still going to look for antivirus in our audit.
Oh, sorry.
Yeah. It's not, yes, totally set up. Great things about CoreOS. But at the end of the day, I don't think compliance sometimes moves as quickly as the technology. While they're often written a little loosely, it still says you should run antivirus. For this, ABAC, ABAC, don't mess with it. You reload your API servers on every change. Same with if you're using tokens. Pain in the ass. You can run an HA setup and try to do them one at a time. RBAC is great. I know that just 1.6 went into beta. It's been rock solid. The examples they have in there for getting it set up, awesome. Just be very cautious of your kube system namespace, I recommend. Underneath for your authentication into your cluster, Vault. There's actually a great DigitalOcean blog post about using Vault for doing your management. I don't know if anyone's looked at doing Kubernetes across multiple regions or multiple data centers, but that's how they're solving this issue. And webhooks, but I don't know if anyone has any experience with the webhook setup. I haven't seen one like awesome. I'm hoping we get SAML at some point. So for the regularly monitor and test networks, there's lots of security to be sold you. Personally, for our company, we went with Alert Logic because we're a small company. It's not just necessarily they provide us with software, they provide us manpower. So we deploy agents into our data center. They do not officially support CoreOS. We took their Debian image, we built it into a Docker container. We'll be throwing these up in our innRoad GitHub if you have any interest. These connect back to the host, feed data into the Alert Logic data center, and they're going to monitor for any kind of security events, escalate when needed, but you kind of get that human verification before they wake anyone up. The other good feature is if any of your additional software you want to run with it is compatible with syslog, they will read off of that and you can pipe additional things in as long as they can parse the data out. Really, really powerful because there are not a lot of tools out there for Kubernetes or even just Docker at the moment. The two companies that are going to come up are Twistlock and Aquasec. And Aquasec we walked away from because their pricing, but secondly, they're not even at the Kubernetes level. They're just integrating with the Docker daemon. And not that necessarily that's a bad thing because everything still pretty much executes through the Docker executable, but the Kubernetes API is a really, really easy source to get information from. So the features there, they're going to scan during builds. They can block pushes or fail builds when you're failing your CVEs if you want to enable it. It is also kind of archaic. TeamCity and Jenkins personally. Circle CI is great. Defender is going to be a daemon set you pump to your entire cluster. What it's going to do is interact with the console application. You're going to set rules that say, blacklist any image from this repo, blacklist images failing major CVEs or with a really, really low score. And it's going to make sure that this gets enforced to have security, provides a great audit log, and you can also lock down your Kubernetes API with Twistlock. We're in the process of our evaluation right now. They have a very, very beautiful demo. like if you guys are I'm typically not a security person. I find this incredibly boring, but they made this a little more pleasurable and not dull. Hopefully better than I do. But what they give you as far as a deployment artifact is completely crap. I really would like to have strong words with how they could improve that, but hopefully, product evolves, great stuff. But once you get going, the kind of visualizations you start to get from it are great. Because in this cloud infrastructure, we're constantly building, but no one goes and they sit there and they draw like, all right, well, this container is going to be on this node, and then he's going to be connected to a load balancer on this port. These things we kind of just given up on in the abstraction, and we need to audit it, but we don't necessarily need to draw it and then hard code everything in. Obviously, for this part, external pen testing, Datadog, other monitoring, just on top of it, make sure everything's running safe, but we all know these. Really great flags in the API server. These guys are just going to audit your log, grab them, send them somewhere else. There's just no mystery once you do this. It's also really great for troubleshooting once you've gone to RBAC and knowing what's blowing up on you. So this is all fun. We're in a situation we have to keep our entire network in scope. These days are changing. We're currently taking our payment infrastructure and we're just stripping it out of our entire application, and we're going to stick it somewhere else. Lock that network down. And not that we won't maintain security on the other network, but with a smaller footprint, you can buy more expensive tools. With a smaller footprint, you need a smaller team to manage it. With a smaller footprint, headaches just get smaller. By doing all of our communication over the HTTPS over the internet, we treat it like a third-party service, even though it's run in-house. But we no longer end up in that situation with, well, someone wants to spin up Periscope in production to check something, and that's going to violate compliance. So no, you can't do that. Not Periscope, Telescope. I forgot the name of the software that you just showed. I apologize. Telepresence. There we go. Awesome. And if possible, get rid of your payment. Send it to an outside vendor. My biggest recommendation ever. There are so many out there that integrate great, like Stripe, Braintree. With our security, we've still got a little bit of a roadmap to go. Calico is, the favored implementation for doing network restrictions. Right now, we store no stateful applications inside of our Kubernetes cluster, so we've kind of moved away from it. All of our APIs are public within our internal network that we run in our kube cluster. So it's kind of not there yet necessarily. We're still fine-tuning our container. That's why we haven't released it. We will be publishing antivirus, alert logics, agent, and then I think there's one other out in our GitHub. At some point, those will become available. But we want to make getting compliant applications a little easier. The biggest thing is so few are doing this at the moment, and if you actually look at the current security analysis, more and more credit card leak is happening with inside companies as time goes on. A big headache we had found was with AWS, every time you spin up a service, and especially with microservices, you provision a new security group, and then that security group needs to have access to your kubelets. Once you hit past 50, this craps out. You can have them increase the limit to 100, but it's not necessarily resolved. You could stop writing services, load balancer services, and switch to node ports, and then do this manually and create other things, but services are just so much better. If anyone has good recommendations for this, I'd love to hear it, but it's kind of something we've been dealing with. And right now, whenever you create the load balancer, it opens up all ports from the load balancer to the kubelets, which, allowing that load balancer in, it's very, very small scope, but it's kind of not clean when clearly the Kubernetes service knows what ports should be allowed. Pull requests at some point. So security is really boring. I apologize. I'm just trying to ease a burden that hopefully none of us have to deal with every day, but I know it comes up. For a little demo stuff, some of the stuff we've done at innRoad, I don't really want to show our consumer application. It's not exactly exciting, but I will show how we implemented Jenkins over top of Kubernetes. Let's switch back to, so when I joined, we really loved the idea of Kubernetes and we wanted to implement it more and more. So we were reevaluating our CI/CD solution. When we did this, we were looking at TeamCity, Jenkins, Bamboo, I think at the time had just hit end of life on cloud, Circle CI, Travis, all the big stuff. And we realized that we still wanted to run our integration tests on our build agents. So because of that, we had to have an internal network presence, which again limits scope. And we started digging into Jenkins, and we like the pipeline model that was released end of last year. It was fantastic. It kind of gives you that really nice interface where Circle CI or Travis gives you your YAML file in your repository. Developers can manage the config very, very easily. It's source controlled. You can branch it, test it, update it. Great. Like the software development lifecycle continues and it works better, and we love it. So, the only bad thing was they decided to implement it inside of Groovy instead of basic YAML. But beggars can't be choosers. So we ended up with, this nice little script that's basically, in all intents and purposes, a shell script. It's just executing arbitrary shell commands to build it and then push our image to the Kubernetes cluster. What I really like about our solution is this is our build agent right here. It's about 4 lines. We inherit from a base image where we just install the Jenkins agent. But every build now in our system is an individual container, just like if you were using Quay, just like if you were using Circle. The Jenkins Cloud implementation is beautiful. We never have to worry about someone tarnishing a build image. If there's a dependency missing and you need it immediately, you just go into your branch and you say, npm install or apt-get update or whatever. And it's fast. So quick repo. I guess we'll just update the Jenkins file so my developers aren't mad. Oh, apologies. So just recap real quick. I just add some spaces into our Jenkins file and threw it in. So Jenkins is listening to the repo. It's all right. It should have a build queued up if I was logged in. Right now it's going and it's launching a Kubernetes job. Throws up our node agent, passes the code down, begins doing the build. When it's done, the job framework handles the cleanup and everything, and we get all of our artifacts. No one outside of the developer has to have any special knowledge to manage this. We just basically implemented a template. You modify it with your code base, save it, you're done. You don't get to 100 or 1,000 microservices having another team that has to write the builds or manage the build server. It's an absolutely tiny footprint. I will say there was a lot of time that went into the thought of this just to get all the components working correctly, because for some reason in the open source community, documentation is always not the first thing they worry about. Or ever, yeah. When you're sitting there in the source code and you're like, oh, I guess that's how it works. This is it. We also are burning off resources we don't use in our dev cluster, so we can try to minimize the imprint. We don't have long-running build agents. We don't have anything static. Everything is testable at this point. So with that, I will, any quite a wide landscape for a demo, but I will be happy to take questions about anything. Also, my info too, if anyone wants to chat about security, about Jenkins, about Kubernetes or implementing things, we don't actually create EC2 instances anymore. We're kind of retiring that idea at innRoad. It has to be kind of like an extreme edge case. So if it's possible to get into a container, we're working to do it.
Ingresses can replace services pretty nicely. I had some problems with Jenkins recently at running it over a service, and then I moved it into an ingress, and no issues. Very simple. I'm using the Nginx ingress right now.
Okay.
It's pretty nice.
I would love to chat more about that. Yeah. Sounds good.
Anybody else? All right. Thank you so much for sharing your journey. Thank you for showing up. We have some time. Feel free to mingle, meet other people, chat. We still have some Taco Tuesday food there for you, and pizza. So hang out, mingle, and if not, see you in June. Thank you for coming.